Hey everybody, it's Lon.TV, and we've got an update today on my home network because I made a few more changes to it to accommodate the fast internet connection that we had. Now, if you missed it, I did a whole series on getting hooked up with the Comcast Gigabit Pro service. This is a fiber to the home product that they offer that is super fast. In fact, it does typically about 2 gigabits per second in both directions, and that's just on one leg of the service. They actually have two legs. One is a 2 gigabit connection, which we're testing here, and there's also a second 1 gigabit leg as well, and you can use both at the same time. Definitely check out my video for more information about that. But this is the upload speed that we're getting right now. I went from 12 megabits per second upload to this, which has been awesome. But one of the challenges that you run into when your internet connection is running at faster than gigabit speeds is that most consumer networking gear only runs at a gigabit. So I was not going to be able to make use of this connection that I was getting unless I made some upgrades around the house to get things going. And I'll show you my setup in a few minutes, but basically what I was doing prior to this past week was running all of my multi-gigabit stuff through this Netgear 10 gig switch that I bought a while ago. And I was connecting this SFP Plus connector to the router. And then I had these 4 ports available for multi-gigabit connections, but that's all I had available for multi-gigabit connections. So I went out and was about to buy a new switch for my rack in there, and a friend of mine called me up and said, hey, I've got an extra one of those things that you're looking to buy. Would you like to buy mine? So I bought his used 16-XG. This is a Unifi aggregation switch. And what this has is about, looks like 16 10 gigabit ports. You've got 4 RJ45s for plugging in network patch cables, and you've got a bunch of SFP Plus ports here for using all sorts of different types of connectors, which I'll show you in a minute. So I've added that to my rack, and I wanted to show you what the rack is looking like in this video. And if you are offended by poor cable management, you're going to really not want to watch any further. But if you want to take pity on me and give me some tips as to how I can fix the problem that you're about to see in a minute, please let me know down in the comments section, and we're going to do an update with that change, hopefully in the near future. But right now it's a little rough in there, just to forewarn you. Now, I do want to let you know, in the interest of full disclosure, that some of the things we're going to be looking at today came in free of charge from the manufacturer, and a lot of the other stuff that you're about to see today I bought with my own funds, and I'll point out which things came from where as we're working our way through the tour here. All the opinions, though, you're about to hear are my own. No one is paying for this review, nor has anyone reviewed or approved what you're about to see before it was uploaded. So let's get into it now and see what kinds of changes I made to my network. Now, prior to getting into this multi-gigabit stuff, my experience with networking had largely just involved the RJ45 connectors that you see here on this gigabit switch. And all I would do is just plug Ethernet cables in and interconnect stuff, and all was good. But now that we're moving on to some more complicated stuff, we've got to learn about SFP and SFP Plus connectors. So if you take a look at the switch that I just installed, you can see that 12 of the ports on it require some kind of module to be installed first before things can get interconnected. It only has 4 of the standard RJ45 Ethernet connectors on there. And I have 2 examples of an SFP Plus connector here on the desk, and I've got a few more that are installed in my equipment room that we can check out in a few minutes. This one is called the SFP 10G-T. It's made by a company called WeTech, and I bought this on Amazon the other day. And the reason why I went with this is because it adds another RJ45 connector to my switch, and that can be really helpful. And the reason why I picked this particular module is that it supports additional speeds that many other modules I've looked at do not. So if you look here on their product specifications, it supports 802.3BZ, which is the 5 gig and 2.5 gig standard for Ethernet. And I've got a few 2.5 gig devices around the house here. I've got my iMac on the desk. I've got a 2.5 gig switch out by my kitchen. And so this will be helpful for interconnecting those. But I also have the option to later plug in a 10 gig connection if I want as well. And again, I could not find many modules that worked with all of those different speeds. Interestingly, the 4 connectors on that Unifi switch that I just put in only support 1 gig or 10 gig connections, not 2.5. So this module will be pretty useful for that. and I'll show you how I'm getting everything interconnected in a moment when we jump into the room. And this one is a passive direct attached copper cable. Couldn't be simpler. You've got a copper cable with two SFP Plus modules molded on at the factory, and you just use this to interconnect two different devices by plugging into their respective SFP Plus ports. Pretty simple to use. What's good about these is that they don't consume all that much power. And one thing that I learned when I was researching how this new switch that I bought worked is that there is a power budget to how many of these modules you can connect at one time. So if we take a look at the spec sheet for the Unifi switch that we got in the closet there, you can see that it supports a maximum of 4 of the RJ45 modules like this one. I'm not sure if this one consumes less power than the one that Unifi makes themselves, but as you can see here, you can only get 4 of those attached versus 12 of their fiber optic modules. So you do have to be careful about how much power each of these modules is consuming. If I went beyond the 4, the switch might shut down or act erratically in order to preserve its power budget. So just bear that in mind as you're planning out your network. So now what I want to do is take you into my disastrous equipment room and show you how all of this stuff is interconnected. And we've also got a couple of fiber optic modules in there too. So let's have a look. Now before we jump into the network configuration here in the equipment room, I did want to show you the SFP modules that are on my Comcast router here. This is the Juniper switch that they installed when they first got us going. And the module on the right here with the yellow cable is a long-range fiber optic module that is transmitting data about 6 miles from here. It's pretty crazy. It just uses lasers and is basically beaming light through this cable out to the street and then all the way over to the Comcast head end. And we're receiving data over that cable as well. And that's how we're able to maintain the connection on the internet, just from a direct fiber connection coming right out of that module. And there are modules that can go 40 kilometers or more. It's pretty crazy how much range you can get out of these things. And that is what's plugged into the Comcast equipment there on the right. On the left, with an orange cable, is the internet connection that gets onto the local network here. So that orange cable connects up to the Unifi UDM Pro router that, in full disclosure, Unifi sent to the channel free of charge. And that is how we get the internet into my local network here over that orange cable with a short-range fiber optic SFP Plus module. Now, part of the reason why this is such a mess is because I never get rid of things that are working. So basically, my network was pretty much just this top switch up until about a few months ago. So this is a 48-port unmanaged TP-Link switch that I've had for a number of years. It's rock solid. It never needs to be rebooted. Everything on the network was working up until we had to speed things up. So it's still here, and I've got all these crazy different size patch cables just connected to it to all the different Ethernet connections we have around the house. So that was here from the beginning. But now what we've done here is we've centralized the entire network through the new XG16 switch here. Again, this is the one that I bought from my friend with all the SFP ports on it. And the reason I'm using this switch as the backbone is that it has the most capacity. It's got 16 10 gigabit ports, and it can transit 10 gigabits of data across each of those simultaneously. So everything on this rack is basically going into the master switch here, which allows for us to really maximize the internet connection. And why is that? Well, let's say I've got a computer that's pulling a gigabit off the internet on this switch, and then I've got another computer pulling another gigabit off the internet on this one. If they were all kind of connected to each other, we would be essentially splitting that gigabit between the two connections. But because everything is running through the master switch now, this switch can get a gigabit and this one can get a gigabit, and I'm able to maximize the connection all the time, which is why you want to have a robust switch kind of being the backbone or backplane of your network, which is what this one does. So that's why we set things up like that. Now the Netgear switch, the one I was using before, is still here, again, because it works. So I've got this one connected to the master switch with this SFP Plus copper cable. I've got the TP-Link here connected to another SFP port here over an RJ45 module. I did that because this is only 1 gigabit, and I wanted to keep these 10 gigabit ports clear for other devices that I might add down here in the future. So those are staying put. And then below the master switch, I have a power over Ethernet switch here. Now, in full disclosure, this came in free of charge from Unifi as well. And 8 out of the 16 ports on here can power devices that are plugged in. So the camera that is currently shooting this image is being powered over this cable, and this cable is also how the image is getting out onto my network over NDI. And I'm going to be basically connecting one wall, or each wall of my studio to one of the 8 ports here, so I can plug these cameras in anywhere. I've got a lot of PoE-powered devices now. Now, the 2 SFP ports on this Unifi switch are not SFP Plus, they're regular SFP, which does a gigabit max. And my copper cables didn't work on these ports, so I had to go out and find something else, and I got a short-range fiber optic connector along with a short-range or regular range patch cable here to connect the PoE switch to the master switch, and it's working fine. Again, a gigabit between here and there, but that's fine for my cameras and everything else. So I'm going to be doing more with this switch in the future. And what's nice is that because this is a Unifi product, I can centrally manage everything. So this switch and this switch are unmanaged. These here are managed switches, and I can go into the control panel and configure individual ports. I'll show you that in a second there. And then below that, we've got the router. The router does have its own Ethernet ports as well. I'm not using them all that much because I might make use of some of the security camera things that Unifi has available in the future. So I want to kind of keep that clear for now. But I do have one thing connected to it right now, and I can't remember what it is, but it was something that I just wanted to have hooked up directly to the router for a project I was working on. So that's pretty much how it's working now. This switch is the master of all of it, and now I've got a lot of capacity for high-speed devices that I may want to add later. I've got 2 more ports on the old Netgear switch. The Netgear, of course, supports 10, 5, and 2.5 gigabit connections, and then I've got all these extra ports here that you can see on the master that are still available to me as well. And yes, I really need help managing these cables. Now, all of the stuff on that rack, plus a WD NAS that works as my media server, consumes about 150 watts of electricity. And I think a large portion of that is attributable to that Juniper switch that came in from Comcast. That thing does consume a lot of power. But you can see, though, that this network is turning into quite a beast, both with equipment, wires, and energy consumption. Now, all of the Unifi equipment is managed via the router, the UDM Pro. They recently added some cool real-time features to it, so you can see what your internet traffic is looking like in real time, both here on the web-based control panel and on their mobile app. If I click on the devices section here, you can see all of the Unifi equipment that I currently have on my network. That includes the router here, the UDM Pro. It also includes our new switch here, the 16-XG. This is that PoE switch that I've got the camera connected to. And then I've got my 3 Wi-Fi access points here as well. Now, if we click on the new switch that is the backbone of our network now, you can see that all of the ports here are represented, and you get a lot of data as to what's going on those ports too. So if we click on the port here with the fiber optic connector over to the PoE switch, you get a sense as to how much data you're transiting. You also get an idea as to the power levels of that particular module as well. And again, that's important for making sure you don't overload things. Now, I did, though, have to go into the config section here and enable flow control because some of my 2.5 gig equipment was not downloading all that fast after I got that new switch installed. So I was getting about 700 megabits or so downstream, and then I was getting the full 2 gigs upstream. And when I turned on that flow control option here, everything started working on the 2.5 gig stuff. So if you're noticing some issues there, definitely make sure that flow control is enabled. And as you can see here, I kind of just feel my way around when I'm trying to figure out how to get stuff to work. And I'm doing this video partly to see if there's some knowledge that you can all give to me to make sure that I've got everything connected up here properly. A few other things I like about the Unifi interface here is that you can get a real-time look as to who's consuming the most data on your network at the moment. So for a little while, I was doing some NDI video from the desktop machine here, which was transmitting video at a high rate over the network to a different device. but this will give you an idea as to what's going on. If you've got something that is transmitting or receiving more than it should, you can go down and chase down the perpetrator to figure out exactly what the issues are. Now, one last thing I want to show you here is the map, which might help to better visualize how we've got everything configured. And what I'm going to do is just zoom in a bit here to get a little bit closer to everything. And as you can see here, we've got the router kind of at the top of the heap. And then we've got my new switch, which has just about everything else branching off from it, with the exception of my MacBook here that's on the desk that is that mystery device that was directly connected to the router. So as you can see here, I've got a lot of devices here that are branching off. What you're not going to see, though, are the unmanaged switches here on the list. It's just going to show us the clients that the main switch here is picking up. But you can, though, see the Unifi access points. So we've got a bunch of stuff connected wirelessly over the sitting room Wi-Fi. You can see what's connected here to the basement, and right now just my car is plugged into the living room one. But it gives you a good idea as to where everything is located. And if I didn't have such a mess in there, they've got a really cool augmented reality app where you can take your phone out and point it at the switches, and it'll show you visually what's connected to each port. So you can walk into your equipment room and not have to look for numbers. You can actually see exactly which device is plugged into where. And that is part of the motivation for me to clean up the wires in there so I can start messing around with that feature, because I'm always moving stuff around, and that is partly why we've got a big mess in there. Now I got one last thing to kind of tease you with, and we're going to do a video on this probably in the near future, which is that my friend also sold me an extra security gateway that he had. Now, I don't need this for my main network, but the Comcast connection that we have includes a second 1 gig leg. So we've got the 2 gig leg that I'm using for the network here for the house, but I've got another gigabit that I'm not doing anything with, a gigabit symmetrical. So I thought what I would do is start messing around with a Synology NAS that I can have available to send files to friends, because right now I'm putting them on AWS. I got to manage the deletion of the files when I'm done, so I'm not charged for storing them up there for too long. And every once in a while I'll do a collab with somebody and I got to send them a 5 or a 6 gigabyte file. And I just don't have room in any of my cloud storage services to really store a file easily. So my plan is to put a Synology NAS over there, set up a reverse proxy, and have this router kind of manage that network for that device, so that when I've got a file to send to a friend, I can just have them connect to that Synology NAS device and download it. So that's going to be an upcoming video here, and we'll take a look at setting up the security gateway for that. Now, one thing, though, we have to bring into the mix with the security gateway is a controller. Unifi has their Cloud Key, which is a hardware controller device, but you can also just install the controller software on something that is on the network with this thing. And I was thinking that the Synology NAS would probably be the best thing to install the controller on, because that's going to be the only thing on the security gateway's network. And I'd love to hear some feedback as to how to best execute that. I'm thinking maybe a Docker controller, but I don't know if I've got some security concerns if I'm also exposing part of the Synology NAS to the internet. So give me some thoughts down in the comment stream, and we'll figure out how to best get this device up and running with the least amount of complexity possible. And even though this is going to be in the same physical location as my other networking gear, it's actually on a separate circuit from Comcast. So it's completely in its own network, and it won't have access to anything that is running on the network that I'm currently using. So that's why we've got to have a whole separate controller set up for this device. So a lot of fun stuff here to work on in the future, including that cable management, getting this thing set up. And I have to say, the network has been working really, really well. I've got my full speed everywhere. I've got a lot more high-speed ports now for adding new things in the future. And I'm really excited to have such a great connection here finally after many years of struggling with a poor one. So more to come on this networking project. And again, leave me your thoughts down in the comment stream, and that's going to do it for now. Until next time, this is Lon.TV. Thanks for watching.
This channel is brought to you by the Lon.TV supporters, including gold level supporters Brian Parker, Jim Peter, Tom Albrecht, Frank Lewandowski, Mark Bollinger, and Chris Allegretta. If you want to help the channel, you can by contributing as little as $1 a month. Head over to Lon.TV/support to learn more. And don't forget to subscribe. Visit Lon.TV/s.